We've done quite a bit of work with quadratic functions. Here's an example of a quadratic function. In the last series of videos, we looked at graphing that quadratic function by first finding its vertex, realizing that since the coefficient of the squared term is positive 1, that the parabola that's related to this quadratic function would open up. And we used that vertex to determine the maximum or minimum value of the quadratic function. So we've done quite a bit of work with quadratic functions. And one of the things that we did along the way is we found the intercepts. Remember, finding the y-intercept is where, because remember, f of x is graphically just another name for y. So when we find the y-intercept, we let x be 0 and solve for y. So in this case, the y-intercept would be negative 10, or would be the point 0, negative 10. When x is 0, y becomes negative 10. And we also looked at finding the x-intercepts. Finding the x-intercepts generally is a little more involved. To find the x-intercepts, remember, we let the function value be 0 and solve the resulting quadratic equation. Now, this particular quadratic equation isn't too bad because the polynomial happens to be factorable. And when we solve that equation, we get two solutions. X could be negative 5 or x could be 2, which gives us the intercepts negative 5, 0, 2, 0. So here are the x-intercepts, here are the y-intercepts, and that's nothing new. We've done that before. Well, what we want to do is we want to take these x-intercepts and go a little bit further with them, talk about them a little bit more in a way that mathematicians like to talk about these x-intercepts. These values of x, negative 5 and 2, they make the function become 0, don't they? They make the y value, because remember, the function is just another name for the y value. They make the function value become 0. Since they do that, since these x values make the function value equal 0, those values are called, and they are real numbers, they are called the real zeros of that quadratic function. So for this quadratic function, x being negative 5 or x being 2 would be the real zeros of this quadratic function. They are also sometimes called the real roots of the quadratic function. Also notice that this factorization is actually then a factorization for the function, isn't it? We could express f of x either in this trinomial form, or we could express it in this factored form, could we not? So this quadratic function, which happens to be an example of what we term a polynomial function. This happens to be a polynomial function of degree 2. We also call it a quadratic function because we've always given the name quadratic to entities that are highest power of 2 or degree 2. So this polynomial function of degree 2, this quadratic function, has a factored form. It factors into those two linear factors. These are linear factors, aren't they? Because the power of the variable is 1. And the roots, the zeros, the real roots, the real zeros of this polynomial function are negative 5 and 2. Because those values, if we put them in for x, make the function's value become 0. They are also the x-intercepts of the graph of that polynomial function. So this is some of the new terminology, the new ideas that we want to deal with here when we deal with polynomial functions.